All right, today what we're going to talk about are angles of elevation and depression. So when you're doing this, the diagrams that you'll be drawing will typically be some type of parallel line somewhere with a transversal. So when we talk about the angle of depression, it is below the horizontal line. So the angle of depression, here's one of your lines, and you're looking down. The angle of elevation would be your other horizontal line, and you're looking above, or looking up because it's above it. So if you notice, these are congruent because they're alternate interior angles. So, and then if you're to draw a right triangle straight down, you make a line straight down, you make a right triangle. Or of course, if you're to draw a line up here, you would also make a right triangle. And then once we got the right triangle, then we can use our trig and inverse trig to find any missing sides or angles. So let's get started. The first thing is it's important to draw a picture because sometimes it's hard to visualize which one's opposite, adjacent, and hypotenuse. So let's go ahead, let's get started. The building is 275 feet tall. So this is your building right here. And it's 275 feet. It casts a 160-foot shadow. So this is your shadow down here. We want to find measure the angle of elevation. So we know we're looking up. So it's this guy right here. Remember, that's theta. We don't know the angle. To the top of the building. The top of the building is right there. So again, we don't need this line here. But these are our parallel lines, and that's your transversal, just so you can kind of imagine where it's at. Now remember, when you're looking for the angle, you're going to do inverse operation. So since we have theta here, we have the building here, this is opposite. And then since theta's here, this is right next to it, this is adjacent. So we're going to use the inverse tangent, which is opposite over adjacent equals theta, which is your angle. So now all you got to do is just plug in your opposite, which is 275, over your adjacent, which is 160, and then just plug that into the calculator and you've got 59.8. Remember to make sure your calculator is in degrees for that. So drawing a picture just helps to figure out what you're looking for. Now on this one, you've got a 40-foot ladder. So this is your ladder. Here's my beautiful picture of a ladder. This is not, Okay, so this is your ladder, and it's leaning against the building. So your building's here, and the ladder forms a 70-degree angle with the ground. So the ground's right here. So we want to know how far from the bottom of the ladder, so here's the bottom of the ladder, to the base of the building. So we're looking for this distance right here, which is x. So they gave us the angle, but we know this is hypotenuse because it's across from the right angle. And since our angle's here, this is adjacent. So we're going to use cosine, which is adjacent over hypotenuse. So cosine of 70 equals x, which is your adjacent, over hypotenuse, which is 40. And then you're just going to set up your proportion, cross multiply, and you'll get x equals 40 times cosine 70, and that's going to be 13.7 feet. So it's not too bad. The hardest part is just drawing the picture to figure out if it's opposite, adjacent, hypotenuse. All right, I want you to try these, and then I want to do number 5 with you. So here we have a pilot flying over ground level at an altitude of 2,400 feet. So your pilot's up here, and he sights a building with an angle of depression. So notice he's looking down. So the building's right here. It's a beautiful building that I just drew for you. But you're looking at the angle of depression is 6 degrees. Now remember, I said that this is a parallel line and this is a transversal right here. So if this is 6 degrees, this part is also 6 degrees. So if you're on the building looking up, that would be 6 degrees there. But now that we know we can use this, we know that this is opposite, and we know that this is adjacent, and we're finding the ground distance between the building and the point directly below the pilot. So here's the building, and here's the point directly below. So we're just finding, to get from here to here, what is it? So in this case, we have opposite and adjacent, which is tangent, and it gave us the angle. So we're going to plug that in there, and then we put that over 1, cross multiply. So you're going to get x times tangent 6 equals 2400, 2400. And then you need to divide both sides by tangent, that's 6. And once you divide both sides, that cancels out and you're left with x, and then plug that into your calculator and you'll get 22,834.5 feet. And this is your final answer. So again, draw a picture, and if you have an angle of depression, just remember that's going to be the angle of elevation on the other way because it's a parallel line. All right, I want you to try this problem, and then I want you to try this problem. Remember to draw a picture. And then once you draw a picture and label it, it's a little bit easier to see what function you need. So that is your angles of elevation and depression.